All right, so today we're going to be looking at objectives 2 and 3 of section 3 of chapter 8, finding the least common denominator. So, yesterday we just added fractions that had common denominators. Today we're going to be looking at fractions that don't have common denominators, but we're not going to be adding and subtracting them yet. We're just going to be saying, what would the common denominator be if we were to find it? So, to do that, you can factor the denominator if it's like one of those trinomials or a binomial that has a GCF in it or something like that. And then once you have it factored, you just take like everything that you see, and if something's repeated, you would just only take it once if it's in both of the fractions already. So what we're going to do, I'm going to start off with an example here of just normal numbers, just so we can refresh on how we did it back whenever we just had normal fractions back in like 5th grade or whatever it was when you first learned fractions. So if you have just two normal fractions, you just look at the denominators, and you can either, some of them you can just do it by inspection, looking at multiples of that number, or you can do the factor tree. So on this one, I'll do the factor tree. On this one, I'll just talk about multiples. So if you remember factor trees, you would do like 8 is made up of 2 times 4, and 2 is prime, and 4 is 2 times 2, and both of those are prime. So 8 is 2 times 2 times 2 as a product of primes. For 22, it is 2 times 11, and both of those are prime. So as a product of primes, it's 2 times 11. So the LCD is, since there's 3 2's here and 1 2 there, you take the most. So you would say it's 2 times 2 times 2, 3 of them, because they have the 1 in common. And then this one has an 11, that one doesn't, so that would be 11. So that's 8 times 11. The least common denominator is 88. So that's the way to do it with factor trees. That way is okay. I don't usually like to do it that way, but 88 would be the common denominator. I'll show you the way I like better on number 3. What I would do is kind of by inspection. So you just say, what are the multiples of 14? So 14 times 1, 14 times 2 is 28, 14 times 3 is 42, and 14 times 4 is 56. So you could do it like that, and then you'd do a few, and then you'll see if 21 makes anything that matches. 21 times 1 times 2 is 42. And right there I can stop. I see 42 is in both of those lists, so 42 would be the common denominator. So that's what you have to do. If the numbers, you look at them and it's not super apparent what the common denominator is. If you look at these, 5 and 15, that's a lot easier, and between 9 and 15, those are not too hard to find the common denominator. So let's look at number 2 there. 7 over 5x and 6 over 15x squared. So again, we're just finding what would the common denominator be. We don't really care about the numerators right now. We're just saying between 5x and 15x squared, what would be the common denominator? So you do it piece by piece. You look at the coefficients, 5 and 15. And that's pretty obvious. What's the common denominator between 5 and 15? Well, 15, right? Because 5 times 3 is 15. I can get it to match it just by multiplying that one by 3. And then for variables, you just take the highest exponent for variables. So between x and x squared, which one's the highest? X squared. So 15x squared would be the common denominator between those two. So that's the key for variables. You just take the highest exponent. So let's look at 4. It's a lot like 3. Okay, so between 9 and 15, this one's a little bit harder. You just gotta think. What are the multiples? Really, I would look at the bigger one, 15. So let's see. It'd be 15, and then it'd be 30, because that's 15 times 2. 9 doesn't go into 30. And then 15 times 3 is 45. Does 9 go into 45? Yeah, so 45 is going to be the coefficient between 9 and 15. And then the variables is the easy part. You take the highest exponent. So between y and y cubed, it would be y cubed. So 45y cubed would be the common denominator, the least common denominator, the LCD. If we look at 5, these ones are very easy. Between x plus 2 and x minus 2, with addition and subtraction, they're kind of their own separate things. So the common denominator between those two things is just going to be x plus 2 times x minus 2. You just stick them next to each other whenever there's nothing really in common. So with addition and subtraction, if they're not the same, you just stick them next to each other. So 6 is the same. There's an x and there's an x plus 4. Since this one is x plus 4, it's its own thing. So the common denominator is just going to be everything mushed together. X times x plus 4. 7, very much the same. Y minus 5 and y minus 4, the common denominator, just mush them together. Y minus 5 times y minus 4. Okay, so number 8 is a little bit tougher. We look at this denominator and we want to factor that. There is a GCF, right? They're both divisible by 3. If you divided by 3, you'd be left with 3 times m plus 5. And this one, remember that m plus 5 squared means m plus 5 times m plus 5. Okay, so we've got them completely factored, the denominators now. And then we just look at what is all the unique things. So the 3 is unique, it's its own thing. There's an m plus 5 in common, so that would take care of each of those. But then there's another one, so there has to be the another m plus 5. So, and then if you think about back at the start, this is a higher exponent, right? The squared is higher than the first. So you could write this, if you wanted, as 3 times m plus 5 squared. And that would be the common denominator there. Number 9 there at the bottom. Okay, this one, hopefully by now you look at that second one and you're like, well, that's not in the right order. If you were to put it in the right order, it would be negative x plus 2, right? And then remember, you don't want your first term to be negative, so you would factor out the negative, and that would leave you with negative times x minus 2. So this denominator is x minus 2. This denominator is really a negative times x minus 2. So what would be the common denominator between those two things? The negative and the x minus 2 that's in common between them already. So that's the common denominator, that own denominator. Okay, on the back, so this one, they're saying if this was my previous denominator and I need my new denominator to be this, what would the new numerator be then as well? So all you have to do is kind of figure out from here to there, what did you multiply by? So I just draw a little arrow, and I say from 9 to 27, we multiplied by 3. And then from a to now a squared, there's an additional a. And then from no b's to having a b, there would be a b. So to get from 9a to 27a squared b, you multiplied by 3ab. So if we did that to the bottom, we have to do the same thing to the top. We have to multiply it by 3ab. So 4b times 3ab. 4 times 3 is 12. There would be an a, and then b times b is b squared. So the new numerator would be 12ab squared. Okay, number 2. Okay, this one's a little trickier. Notice this one is factorable. So if it factors, you probably want to factor it. So there's a 3 in common. If you divide by 3, you're left with 2x plus 5. So now it's very apparent. From this denominator to that denominator, what did they multiply by? Just 3, right? If we multiply the bottom by 3 of a fraction, you have to multiply the top by 3. So 7x times 3 is 21x for the new numerator. Okay, number 3 here is, again, this one, you want to look at that, and you probably want to factor that. It is a difference of squares, right? Subtraction, 2 perfect squares. So it factors very easily to the square root of the first term, which is x, and the square root of 4, which is 2, 1 plus, 1 minus. So x plus 2 and x minus 2. And look, from previous denominator to new denominator, what is new? I've got the x plus 2 already. I've got the x minus 2 already. The only thing that's new from here to there is they multiplied by an x minus 4. So if they multiplied the bottom by x minus 4, we have to multiply the top by x minus 4. So you could probably just leave it as 5 times x minus 4, or if you wanted, you could distribute and write 5x minus 20. Either of them would be fine. If you want to take a moment right here and pause and try 4 and 5, you can, and see if you get it, or if not, we'll work them together as well. All right, so this denominator here factors. That one's already in its factored form, so there's a 3 in common there, which would leave you with x plus 2. So then you just have to look, inspect by your eye from here to there. What's the only thing that's new? The y, right? So if the top gets multiplied, or if the bottom gets multiplied by y, the top also has to get multiplied by y. So I would probably just leave this one as y times 4x plus 1. If you went ahead and distributed and got 4xy plus y, that would be fine as well. And then number 5, again, this one's going to factor, and then we'll see what's new. So between those 3 terms, there's a GCF of x, which would leave you with x squared plus 6x plus 8. From there, you would factor that trinomial, and since there's no number in front of that first term, the squared term, we can go directly into the parentheses. So we're just, if my third sign is positive, I adopt the sign of my second for both. So it's going to be x plus something and x plus something else. And the numbers are the factors of 8 that add to 6. So how do we get to 8? Well, 8 is either 2 times 4 or 1 times 8. And the ones that add to 6 are, of course, 2 and 4. So we just drop them in, and that's the one. So now it's completely factored. I'm going to cross those out so I don't confuse myself, and then I just have to look from here, this previous denominator, to there, the new denominator. What is new? The only thing that's new is the x plus 1. So that means the top would get multiplied by x plus 1. And you could leave it as x times x plus 1, or you could distribute it and write it as x squared plus x. Either one is perfectly fine. So again, if you have any questions, please reach out to me on Google Hangouts. I'd be happy to help you out there, or email me, or whatever works best for you. Good luck on your assignment. Let me know if you need anything.